Imagine a time before time as we know it. Picture a universe without a single star to light the way. It is a concept that is difficult to grasp, an emptiness so profound it really defies our everyday experience. Today we look up at a night sky filled with countless points of light, each a distant sun, many with their own families of planets. This cosmic spectacle is the only universe we have ever known. But if we could travel back, far back, to the very dawn of existence, we would find a very different cosmos. We would find a universe plunged into an all-encompassing darkness, a period astronomers call the Cosmic Dark Ages. This was a universe waiting for its first spark. The Big Bang had happened. The initial, unimaginably hot and dense state of the universe had cooled enough for the first fundamental particles to form. Protons, neutrons, and electrons swirled in a primordial soup. For about 380,000 years, this soup was so hot and dense that light itself was trapped, unable to travel freely. The universe was an opaque fog. Then, as it expanded and cooled further, a moment of transition occurred. Electrons were captured by atomic nuclei, forming the first stable atoms of hydrogen and helium. Suddenly, the universe became transparent. Light could now travel across the vastness of space. But there was a problem. There were no sources of light. This era of profound blackness lasted for hundreds of millions of years. It was a simple, quiet, and incredibly dark place. The only light was the faint fading afterglow of the Big Bang itself, a background radiation that had stretched and cooled until it was far beyond the visible spectrum. To any observer, the cosmos would have been utterly black. The great clouds of hydrogen and helium gas drifted silently through the void, pulled gently by the invisible hand of gravity. It was a universe in waiting, a stage being set for the grand drama of cosmic evolution that was yet to come. The first stars were still a distant promise, their fiery birth a future event of unimaginable significance. But what if this darkness was not empty? What if it was not entirely lifeless? We are accustomed to thinking of life as a product of stars. The timescales involved in the early universe are staggering, almost beyond human comprehension. We think of our own lives, or even the history of our civilization, as long periods. But these are mere flickers compared to the age of the cosmos, the Cosmic Dark Ages. This period between the universe becoming transparent and the first stars lighting up is thought to have lasted for perhaps 200 million years or more. It is an immense stretch of time. To put that into perspective, the dinosaurs roamed the Earth for about 165 million years. To even begin to talk about life, we must first talk about chemistry. Life, at its core, is a complex chemical system. On Earth, it is based on the element carbon, which can form an incredible variety of long, stable molecules. It also requires liquid water, a solvent where these molecules can meet and react. In the early universe, the chemical situation was much, much simpler. The cosmos was composed almost entirely of the two lightest elements, hydrogen and helium, with only trace amounts of lithium. This seems like a major obstacle. How could you build anything complex, let alone alive, from such a simple chemical palette? The formation of molecular hydrogen, H2, was more than just a chemical curiosity. It played a vital role in shaping the future of the cosmos. This simple molecule had a property that individual hydrogen atoms lacked. It was an excellent coolant. Atomic hydrogen is not very good at radiating away heat in the cold conditions of the early universe, but a hydrogen molecule can. When H2 molecules collide, they can become excited. Every living thing requires energy to maintain its structure, to grow and to reproduce. Life is, at its core, a constant battle against entropy. On Earth, almost all life is powered by the sun. Plants use photosynthesis to convert sunlight into chemical energy, and animals get their energy by eating plants or other animals. In the Cosmic Dark Ages, there were no stars to provide this energy. The universe was dark and cold. So if any form of life were to exist, it would need to find an alternative power source. The answer may lie in the fading glow of the Big Bang itself. After the universe became transparent, the light from the Big Bang, now known as the Cosmic Microwave Background, or CMB, filled all of space. For the first few million years of the Dark Ages, this radiation was still relatively warm. It cooled over time as the universe expanded, but between about 10 and 17 million years after the Big Bang, the temperature of the CMB was between 100 and 0 degrees Celsius. This is the temperature range of liquid water. During this specific epoch, the entire universe was gently warmed by the afterglow of its own creation. It has been called the habitable epoch of the early universe. As we venture into the realm of possibilities, we must first confront the most significant hurdle for life in the Dark Ages, the profound lack of chemical diversity. Life on Earth is a testament to the versatility of carbon, an element capable of forming an astonishing array of complex, stable molecules. This molecular scaffolding is supported by other crucial elements like oxygen, nitrogen, yet in the early universe, these elements simply did not exist. The cosmos was a stark and simple place made almost entirely of hydrogen and helium. Another major challenge for our conventional ideas about life is, honestly, the absence of a stable home. We tend to think of life as a planetary phenomenon. Life on Earth began in the oceans of a young, rocky world, a stable platform where chemistry could unfold over billions of years. Our planet provides a contained environment, but in the cosmic dark ages there were no planets. The universe was just a vast, diffuse sea of gas. Perhaps life did not need a solid surface at all. If we accept the challenges of the elements and the lack of planets, we are really forced to imagine what life might look like in such an alien context. The setting would be a vast, dark ocean of hydrogen and helium gas. Any life would be a creature of this ocean, a free-floating entity without a solid ground beneath it. It would have to maintain its structure and integrity against the diffuse, chaotic nature of its surroundings. Instead of being made of cells with membranes, perhaps these life forms were more like self-sustaining vortices or stable patterns within the gas. Let's delve deeper into the most plausible, yet still highly speculative foundation for pre-stellar life, a biology based on hydrogen. Given that hydrogen was the most abundant substance, it stands to reason that any life would have had to make use of it. While we see hydrogen as a simple fuel, its chemistry can be more complex than we often assume. A leading hypothesis proposed by physicist Avi Loeb suggests that complex chemistry could have emerged from these simple ingredients. The idea revolves around the formation of more complex hydrogen molecules. Our journey through the cosmic dark ages brings us to an inevitable conclusion. The darkness had to end. After hundreds of millions of years of quiet, patient contraction, the densest cores of the primordial gas clouds reached a tipping point. The pressure and temperature became so extreme that a new fire was lit in the cosmos. The first stars ignited, flooding the universe with light for the very first time. These were magnificent, monstrous stars. These first stars were not just sources of light, they were the universe's alchemists. In their fiery hearts, they fused hydrogen and helium into heavier elements. When these massive stars died in spectacular supernova explosions. So what does this mean for our question? What if life began before the stars? The hypothesis remains a profound and tantalizing speculation. It forces us to stretch our definitions of life, chemistry, and environment to their absolute limits. The dark, starless era of the early universe stands as a powerful testament to the fact that the most profound questions are often found not in the light, but in the darkness that came before it.